right. Great. Let's start this talk. So, my name is Rustam. I am a Java champion. I'm a Google developer expert for cloud. I'm also a consultant. I work with a lot of cloud things. And I would like to talk to you about, about plugging HDMI cables into your computer. So that's the lesson number 1 that we'll be all learning today. See, it works. I was like, why is black? So now, cloud native. What is cloud native, and what does it actually mean to when we talk about cloud native and all that? So I would like to start with a little thing. A little drawing. So long story short, last year we're in the month of October. A year ago, we had our Inktober competition, so we ended up drawing things. That was my drawing for the word confusion. Make sense? A bit sad, a bit confused, like spaghetti in the thoughts, and like a little bit disappointed. And then I started building on top of that thing. So that is what I want to start with this talk as well. There was this bad joke on the internet that I made my own version of. Cloud, and then it's like, Dad, what the cloud is made of? A kid asking a parent. Well, it's mostly Linux servers, the dad says. The dad is obviously a cloud developer. And, it's a kind of bad joke, but it's time to laugh if you want to. Thank you. But it kind of really describes when we're talking about cloud native. What is that thing? Like, what do we actually mean by that? And, well, obviously it's small little penguins. I mean, that was my attempt to draw a penguin, if you didn't notice. But, like, what is it? Well, the long story short, another bad joke from the internet. I promise, this is it. The rest of the bad jokes will be coming from just myself. I mean, I can't promise you that I will stop doing bad jokes because that's impossible. But, cloud is basically somebody else's computer. You still have infrastructure. You still have computers. You talk about serverless. Well, they're not really serverless. There's more of them. And all that. But you still have to develop applications in a way that will make your life easier. You're renting infrastructure, you're renting servers, you're renting things, but you still have to develop applications that do not hurt running them. And that's what we'll be talking about. And what I usually like to start with, I mean, when I've done the different versions of different talks, where I try to define cloud native, I really like to show this wall of text to people. And it is like a bad thing and a good thing at the same time, because by now you're deep into that sentence and you're not hearing a word I'm saying. Right? Yeah. To stop you from doing that, I highlighted things. I even removed things. And I even grouped things. So now it makes a little bit more sense. Now you can actually still listen to what I'm saying. It's much less words, more colors, shiny things. But, what are we building? Well, we're building scalable stuff that can run on the cloud. Public, private, hybrid, whatever. How do we do that? Well, containers, obviously. Service meshes, microservices, all these things that have been hyped up and down in all directions for the last, I don't know how many years. Immutable infrastructure, that's a bit new kid on the block-ish. I mean, it's not new, but ish. Declarative APIs and all those kind of things, right? Why do we want to do that? I mean, it's all cool. Conference-driven development and CV-driven development is also very cool. But, like, why on earth do we really want to do that? Well, it is because we want to have manageable applications. It is because we want them to be observable and manageable and resilient and, loosely coupled because, then you can pull them apart and all that. And have robust automation, all those things, right? So this was this is usually a very good starting point to put everyone on the same page. What do we actually mean by cloud native? Probably, if I asked everyone in this room, there will be at least n plus 1. If the number of people here are n, there will be at least n plus 1 definition of what cloud native is. So let's stick with that, okay? The Y part, the Y part, the one that you see up there, that usually means business needs, like business needs that. Well, we need speed. We need something that goes fast to production. I don't mean like a speed in the sense that your application is quick, which is cool, but it's mostly about making your time from an idea to something in production really quick because, it gives you a competitive edge and blah, 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 and all this enterprisey things that make you happy. Or maybe not you, but maybe your manager. So, your customer, anything. It also is about agility, and I'm not really talking about the other thing that we've been all talking about a lot, like agile, but it's agility is the actual word, meaning of that word. Because, you respond to change, you can actually, navigate problems and all this kind of things, meaning that, well, you have a bug in a system, you can easily deploy a fix without having to redeploy all of your application because you have microservices that are loosely coupled and blah, 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 right? It's all about reliability. Nowadays, we really need to think about reliability in many senses of that word as a developer. One of them, the most obvious one, is your application being kind of fault tolerant and all this. But we'll talk a little bit more about that in a second as well. But in this also, here we also mean things like automation, things like scalability, availability, testing. So by availability, I also mean that your application doesn't go down with something happens around it or inside it, right? The second side, the other side of the medal is resilience. So reliability and resilience, they kind of go together. But resilience is more about actually being able to respond to faults. So there was a session just before mine where there was a lot of talk about resilience and all this kind of how to do fault tolerance and all this stuff. This is a cloud native thing. It's very important because you have a bunch of microservices. If something fails somewhere inside or outside of your control, in or outside of your control, you still need to be able to respond to that, something failing, without showing like 500 errors to your customers, right? Your users. Well, obviously, security is a thing, and observability is a thing. And as all good developers, I put security last and just security. Don't do that. Really, focus, think about it. Actually, do something about it. But yeah. And, well, the fifth thing usually customers ask, like when they would come to me or, well, to us and say, well, you know what, we want to really to avoid lock-ins. And then people would tend, that's a bit sensitive thing because a lot of people do tend to misunderstand it badly and call things for lock-in that are not. Like, for example, instead of using a standardized cloud-managed database versions, they was like, no, we're going to rent VMs on the cloud, install operating system, install our own database, run that because then we're not locked in. Well, are you? And then lock-in thing is also, it's on different levels, and then you have to decide on which level do you really want to put that, limit. You choose a language to program in. Is it lock-in? I don't know. You choose an IDE, you choose a library. There's a lot of things that where does the line go? It's up to you. It's up to you to decide, really. But most of the times, open standards mean less lock-in. I'm not saying no lock-in because there will always be, depending on how you define it, but less lock-in. Not proprietary solutions, that's definitely a lock-in, but open standards, well, you know. So that's why. What? Well, this is where I'm going to go very quickly through this thing. You have obviously public or private clouds. You have multi-cloud where you go several, 2 or more public clouds together. And then you have things like a hybrid cloud where you do a public cloud plus on-prem stuff, right? So there are different ways of deploying your application, and there will be different ways of on different reasons, and there might be different reasons for choosing one or the other. You know, you want to have like super high availability or super high failover thing. Maybe you want to go for multi-cloud or a hybrid cloud, but sometimes you cannot share your data with because reasons. So then you might go with hybrid cloud because you store data locally, you process it and do something about it outside in the cloud, right? So what you can do, another thing you can do is also you can just basically shop for small things. So one cloud provider has something, the other cloud provider has something, but cheaper. So you can, you know, mix and choose and stuff like that as well. So reasons are many, but this is what we're deploying or where we're basically deploying, right? We're creating scalable applications that can run on all of that. They don't have to run on all that, but they can, right? Now, I promised you the toolbox, so that's the toolbox, so that's where it comes now. Before I actually am going to list things, I'm going to show all those 5 things that I kind of mean and I'm going to be focusing on, and I kind of believe that they are making your cloud native applications more cloud native as opposed to old monoliths that we used to run back in the days, back in the good old days where we just like deploy things on, I don't know, Jetty, on Tomcat or something like that. So loose coupling is a thing, right? So we need to think about making it more loose coupled, but it has its own challenges. You really need, now you have another problem. You know, now you're going from a huge monolith that you really had troubles with deploying and redeploying and all that to a loose coupled thing, which is really amazing, but now you have to think about more things. Now you have to think about microservices. Now you have to think about the architecture of those things. Now you have to think about how those microservices are going to communicate, HTTP, gRPC, all other letters put together and mixed together, whatever. Service meshes, you know, all those things that you really did not have to think where you had just the calls internally in monoliths. Well, containers, right? Because containers are cool. We learned that at all conferences for the last, I don't know how many years. But it's not just that. It's pretty cool because it's predictable builds and it's predictable deployments. And it's really good because usually people think about just one of those things. But your deployments will be very predictable because you know how your container looks and how it runs. You just know that you just put it there and it just runs, right? But it's also predictable builds because if I run it on my machine, on my, I'll know that it runs also on your machine better because as long as we have the same architecture, it will probably behave in the same way or build in the same way and run in the same way, right? And then you have different architectures because, you know, because we like to invent new things, and then it becomes full party. But you know, you can build several like multi-architecture containers and stuff like that, and all this. It's fine-ish. Automation. We want to automate all the things and some more. And when you think you've done automating it, you automate even more, because 1, it saves time. 2, computers make less errors than we all do. At least, I don't know how about you, but you know, I do write bugs sometimes, non-intentionally. I mean, there are people that do believe that they don't. Good for them. Good for you. Well, you know, it's less toil, but it's also the one thing that is not really written there. It's documented. When you create an automation, you actually create a list, a cookbook of how things should be done. And you can put it into a version control, and it's going to be there. Another person will be coming in, and they will have a look, and they're like, oh, yeah, I understand how it's done, and then they will just do it. So it's really cool. Yeah, well, resilience, we talked about that, right? And scaling. So scaling, it used to be called, I used to have this number 5 called serverless. I did remove that because it's not about that. It's more about being able to scale no matter what, if it's serverless or not. But serverless usually means manage less, and it also means automatic scaling. It also means that, but yeah, scaling. Cost reduction, less toil, you spend less money, less resources in a sense of, sustainability and all that. And so there is a bad joke, this I usually say here, is that it's all about, being green. So green money, green environment. In this case, it kind of goes together. You spend less money, better for environment. Good. I know it's a bad joke, but you can't. Yes, thank you. I'm kind of used to doing bad jokes. That's pretty much all of what I do. I don't do good jokes. So Toolbox, right? We have all this long introduction, and let's talk about loose coupling. What does this mean? Like, how do we do that? How do we measure it? How do we poke it and see what's inside and how it works and all this? So there are some good old friends, PMD and JDEPs and all those that we've known for a while. Those are really, really good to inspect your package structures and all these kind of things. They're still useful, so they're there. There are things like a bit more newish things like, Kali and Istio and all the other service meshes, because you need a service mesh, right? You need something to make sure that all your services are communicating, and also to make sure that the communication is doing what it's like. It's secure, for example, right? So, for example, that you're doing SSL encryption in between the containers, because zero trust and all the other fun things. And you don't want to do that manually. You want to have a sidecar, which, if you don't, if you're not careful, it's going to get bigger than your actual container, but that's a different story. You can have a sidecar. You can put a lot of things in it, and then it will fix things for you, right? You obviously have to, now that you have endpoints over HTTP or gRPC or whatever, let's say HTTP for now. You need to document it, and you don't really want to document that manually. You want to do that as automatic as possible, and you want to publish those contracts. Enter OpenAPI and Swagger and all that. Well, Swagger UI is fine, but the most interesting thing, the thing that I'm really mostly excited about is the OpenAPI spec itself, because you can generate it automatically based on most of the libraries, whatever language that you're using. I mean, in this case, I talk a lot about Java, which is fine, but I mean, the other languages will have the same thing. It will generate OpenAPI specs more or less automatically out of your endpoint definitions in your code, and also based on the verbs that you say that you're receiving. So get and put and all that. And you need that for many reasons, and one of the reasons is, well, obviously you can create tests, you can create, what to expect, what errors or what error messages you will be getting, or you can be getting. But also it's a very good thing in a sense that you can put that into other tools that I'm not mentioning here because they're not loose coupling, but I'm still going to do like a honorable mention thing. Things like for collaboration. Well, most of people know let's say, for example, Atlassian stack, right? Most of the people know like Jira and Confluence and stuff, but there is also things like Compass. In Compass, you can just say, hey, here's my OpenAPI spec. That thing will just go in there and generate documentation for everyone to see of your endpoints with all the pretty print of the all that thing, which is really nice. I'm not advertising for any tools. I'm going to be mentioning most of the tools will be open source by design. I try to choose them, but if I mention paid versions, it's just because they're so widespread and all that. All right. Well, containers, well, you know, there's a lot of ways of doing that, right? There is the most known as Docker, Docker Desktop, all this. There's like Kolima to replace parts of it if you don't want to go with Docker Desktop and all that. There is Podman, there is Rancher, there's Kubernetes, there is K9s or K9s, depending on who is pronouncing it, which is a wrapper on top of Kubernetes. Again, there is meshes like Istio and Linkerd and all the other ones. But, you know, you can build your own containers. You don't have to run them on Docker. You can create compatible containers and you know, all the structures and all that with different tools. There are tools to do that, and Google it. We don't have time to go into this, but the point is, whatever you run it on, make sure that it is doing what you want and does not break things, and that you can actually move around to other. Most of the times it will be compatible between the different versions, and sometimes you can just even if you're not, let's say, for example, you're not running Docker, you can still run Podman or something and just create an alias and say, alias Docker equals Podman. And then every time you say Docker PS, it will actually run Podman PS, and it will be working, yeah, as long as they have compatible APIs. Or you can do it the other way around. I mean, whatever you want. Yeah, well, that's all for running locally or in small environments. For bigger versions of that, you have Kubernetes, you have all these kind of things. We'll talk more about building things on top of Kubernetes, but that comes a bit later. Automation stuff. Well, choose your poison, really. I mean, it's not necessarily poison. It's a good thing most of the times. But like, choose whatever you want. Stick with it or change it. It doesn't matter. I mean, I listed some of them. I definitely will not have space to list all of them, but it's just like the most common ones. There is like Argo CD, GitHub Actions, Cloud Build. So Cloud Build, GitHub Action, that's, well, obviously from GitHub, Microsoft. Cloud Build, that's from Google. Well, Jenkins, that's good old Jenkins. Then you have Circle CI and all these things. That's for pipelines, right? That's mostly your CI/CDs. Triggering on commits, triggering on whatever releases, doing all these fun things. Then you have the workhorses that are actually building things first, building artifacts and building all that, and then, you know, then you have all these things like Maven and Gradle and whatever. Ant? Anyone remembers that? Yeah. Well, I mean, I don't judge. It's fine. You want to go Ant? Fine. Automate it. That's the only point. So you need to think about several things, and you need to try to automate all of those steps as much as you can, because it will make your life much easier. And also include, I would put here, I'm going to talk about security more, but I'm going to mention security here as well, that you should actually automate, you know, creating SBOMs and, you know, all the other things that are more security related, creating a bill of material and all that, but also scanning your stuff. Create automatic scans of things, because I'm going to mention it in automation, and I'm going to mention it again in resilience, because it is part of the resilience, but it's also part of automation. Automation does not mean just create a pipeline and just leave it there. You want to do it much, much more. You want to make it in a sense that it will be easy to deploy. A lot of people nowadays don't really see the platforms like Kubernetes and stuff. They build stuff on top of that, where they would just put a YAML file with their applications will be just automatically deployed, right? Because all those things like Kubernetes and all that, they bring a lot of complexity. It's not just like, oh, yay, everybody's doing Kubernetes, let's do that. You really need to know what you're doing. It does bring a lot of complexity, and now we're trying to hide that complexity behind YAML, because writing YAML is, I guess it's fun. I don't know. I'm not really sure, but indentation can be interesting to handle. I thought we learned that when we were programming Python, but apparently we didn't. We do parentheses and stuff, but yeah, okay. Anyway, no, we're not going there. We can go there later in the evening or something. But resilience. So resilience is a very important part of this modern, so like what I'm talking about now is a modern Java application. So app modernization is a thing, right? People talk about it, people mention it. And this is all about being able to run in a sense that you can actually have a look inside, have a look and understand how it works, how it behaves, and all this kind of thing. So resilience is one thing, and a lot of things that are built in Java world for resilience are based on resilience for J. So resilience for J is used in implementation by the microprofile and a bunch of others. So it lets you control how your application can behave when there are outages, when there are errors, when there are exceptions, and all this kind of things. And by the way, I mentioned some, and I would really, really be happy if anyone raises a hand and says, you know what, in 4 points, whatever, 1, 2, 3, 4, and 5, that will come later, you should have mentioned something else. Because this is about trying to learn things from each other and trying to, and it did happen. I've done this talk a couple of times, and then people will be like, yeah, you should probably add this. And I did add some of those things, and some of them I didn't, but it depends. You know, you can't put everything, but most of the things are actually ended up being there. So feel free to raise your hand at any point and just say, you should have this. Cool, yes? GitLab automation, exactly. So since I mentioned GitHub, I should mention GitLab. Thank you. Yes? Come again? Oh, okay. Okay, cool. Yes, thank you. One more, yes?
There are a lot of tools for OSGI integration for the cloud that give you more control over the inputs the stream does.
Cool. That's, yes. So, yes, exactly. So then you have OSGI as well. Okay, yes. That's, do you have any tools like that you, off the top of your head, that you want to mention? I should probably repeat for the microphone, but I'll do that afterwards. It's fine.
Yeah, I have to go back and give you a list, but there's
Yeah.
quite a lot of tools there. END tools are a great thing.
Cool.
Testing tools.
Testing tools, yes. So testing, I think I have it. Where do I have testing? Oh yeah, I do have testing in loose coupling, but because I didn't know where to put testing things. But yes, in general, yes, also for OSGI, but in general, things like load testing, unit testing, and just generally testing of your containers. Because now that you're doing loose coupling, your comment just made me realize that I forgot to mention testing. So thank you for that. When you're doing containers, you have a problem of being able to test things easily. And that's where test containers come in, where you would just like spin up random container, well, not random, but like any kind of container, a database, another API, another thing, and just do testing against it and just kill it afterwards, and then it will be gone, but you will still be able to test things. That's a really, really nice thing. And then you have Gatling, for like load testing and all this kind of things, and you have unit testing and all kind of testing, end-to-end testing. Everything needs to be even more done even more than you would do with monoliths. Yes, sorry, I went on a totally crazy rant about testing. Any more comments? Yeah, I have Jenkins there. Good old Jenkins. Anybody else? Going once, going twice. I almost saw a hand, but okay. Three times? No? Okay, cool. Let's go for the fifth one, see if I can provoke more comments. Well, it's about scaling. And scaling actually means, like I said, it's two things, right? It's about resources and how much money you spend on resources that are idling. But it's also about environment, actually saving environment, saving those. Now we're starting measuring environmental impact in water bottles that I've heard. Like, it's like, oh, this AI thing costs or uses up 3 water bottles, or something like that. I mean, it kind of makes sense, but we can measure it in many things. We can measure it in CO2 emissions or any other kind of things. But it really is useful, and it's useful to think, can you scale? Can you actually, whenever you're creating things, maybe you do not need Kubernetes cluster running that. Maybe you can actually do serverless. Maybe you can do something like that. So Knative is one of those things. Knative is a serverless offering, or serverless that you can run on-prem or somewhere else. For example, Google has something called Cloud Run, which is a kind of Knative. It's a Knative with a little bit extras. It can do both events-based things and also kind of just regular good old services and stuff like that. You have Kubernetes, you have a service mesh that used to be Istio, but now I think it is Linkerd, if I remember that correctly. It's a service mesh, and then it's a Knative on top of that. There is also a thing called Kera, and that's also really cool because relatively recently, at least, well, some time ago, there was a release of carbon, what's it called? Carbon footprint or carbon emission. I think I have it here. Wait. So Microsoft did this carbon-aware Keda operator. I was looking at it just before I started this talk, which is kind of really, really cool thing. Thinking of like, one is like doing serverless and all that, and the other one is actually thinking about your emissions, and it will actually help you to do that. That's kind of really cool thing. Yeah, so there are cloud managed versions of things like Cloud Run, which is kind of managed Knative. There is Azure Container Apps. There is a bunch of other things. Yeah. Scaling is important because, like I said, it's to avoid idling infrastructure, and it's also to be able to give away resources to other applications that might need it right there. So you can actually, balance it out if you're running it on your own hardware, or let cloud providers balance it for you and bill you less if that is the thing, right? Any other tools that you want to add to those 5 categories? Yes.
On number 5, you probably could have included the AWS App Runner.
Yes, AWS App Runner. So yes, since I mentioned 2 others, I should have done that. Yes, I can do that. That's cool. Yes. And by scaling, I actually mean scaling proper containers, because there's also a thing called functions in one way or another, like cloud functions and cloud whatever, lambdas, whatever. I didn't put that here because we're talking about like proper full-scaled applications. So that is also a thing, but that is a bit different kind of animal. Yes. Message service, yes. I didn't know where to put them really. So, but yes, it is. Yes. I'm not sure where though. It probably will go into the box of loose coupling, because when you need to exchange messages, and you can do message-driven things. Yeah, it's a bunch of them. Yes, all the MQs and rabbits and all the other animals and stuff. Yeah. The thing that I didn't really talk about, and I still have like 3 minutes, so I can do that. It's all the tracing and measuring things and looking into how your application is doing stuff. OpenTelemetry, Micrometer, Jagger, Prometheus, Grafana, and then you have actually, now you have, the Grafana people have this LGTM, so looks good to me, kind of abbreviation. They basically created products to make it look like this. I think it was deliberate action anyway. But the point is that you want to measure how things are doing. You want to put that, you want to do telemetry. You want to do also to see how long time is between different calls of your application. So there's a lot of things that you can implement, like tracing, so you can actually know how your application is doing. You just, because otherwise you'll be just knowing, well, request comes in, request goes out. You wouldn't know anything that happens in between those two things. So that's cool. Yeah, Tempo is a time series database where you can put things and see how it behaves. And then you have all these things that I mentioned already: security scans of your containers, security scans of your code, static code analysis, like things like, for example, SonarQube and all that. And I had to put secret managers somewhere, so I put them there. But that's because you're not supposed to put them into the configuration files or any other places in the code because, you know, security. Right. 1 minute left. Just sharing some resources, just since we're talking about cloud and the security and all that. I did write a few blog posts about that, so there are a few links to that. There is a different talk that I do sometimes called 5 features. Well, it's a different name, but yeah, it's all about showing off 5 features, things like fault tolerance, metric health, feature toggling, and all these things with Jakarta E and microprofile. So if you want to have a look into the whole application and see how it runs, you can go there. And there is also much smaller string, random strings application that we've put together that has other things, like very simple examples, but also it shows how to deploy it to cloud and also shows you how to optimize it for cloud and things like that as well. Yeah, this is me. This is how you find me on social media. This is me on Twitter, but I put all the links to social media onto that website, rustam.no. Just go there or scan the QR code, and then you'll find me on whatever you like of the social medias. I think I should be on the most of them. And yeah, thank you all for coming. Enjoy the rest of the conference, and thanks for all the comments and things that you've been mentioning.